I'm a water quality scientist with the Otago Regional Council, and I've been lucky enough to be tasked by Council to support the lake monitoring program that we've had running since September 2016. It's an intensive monitoring program that's going to run for at least another 3 years and possibly beyond. Also, part of that monitoring program is also trying to collect more specific information on the lake snow diatom, which will help the scientists and the community sort of better understand what the drivers are with the lake snow. So this weekend we've had Professor David Hamilton down from the University of Waikato, and David's been kind enough to bring down some of their flash lake monitoring equipment that provided us with a fantastic opportunity to collect a lot of really useful information about the functioning of Lake Wanaka, particularly towards the end of a summer.
Well, it's an instrument that we use to vertically profile the water column. So what that means is that as we lower it through the water, it's taking a series of readings, and it's doing these readings 4 times a second. We're taking readings of temperature, dissolved oxygen, chlorophyll A, which gives us an indication of the algal concentrations in the water, conductivity, an idea of the salt concentrations through the water. Today we dropped it through about just over 300 metres, one of the deepest points in the lake. What we have is more or less a continuous profile as this goes down to the bottom of the lake and then back up again. So it provides a tremendous amount of information to us. One of the drivers for this has been the lake snow. The lake snow is produced by a particular type of algal species. So this instrument is designed really to try to understand whereabouts are those algae, whereabouts are they growing, and what might be the factor that's driving them to produce all this sort of mucus. Okay, this one's a biofish, and this is probably our most sophisticated piece of lake-going equipment. It complements the instrument that we use to take a vertical profile by essentially running horizontally across the lake. But as it runs horizontally, it has these wings, and we can control the pitch on the wings. So we drag it behind the boat up to about 90 metres behind the boat. We adjust the pitch on the wings, and we basically try to make it undulate and essentially sample the top 70 or 80 metres of the water. As it does that, it's taking readings 4 times a second. And so it's taking readings of light, temperature, conductivity, a measure of the salt concentrations in the water, the oxygen concentrations, and the chlorophyll concentrations. And those chlorophyll concentrations relate to the algae that's in the water, and the one of particular interest is the lake snow. So we've certainly got some interesting information to now process. We've been out for probably about 14 hours or so over the weekend, and what we'll do is download that information to the computer and then try to essentially visualise the whole of the water column to see what's there. To some extent, to us, it's like a little bit of exploring the unknown. I can't wait to get back and plot it up on the computer and just see what we're going to find down there.